Hi everyone, I am Gautam, physics faculty. Now I am going to discuss series combination of two rods. This is the first rod attached from the rigid support. So the length of this one is L, cross sectional area is A. These are initial values. And Young's modulus of this particular material, let me take it as Y1. Now, at the end of this rod, end of the first rod, I am attaching the second rod. Such type of combination is called series combination. End of one rod, we attach another rod, like that we are going on attaching in this way. We call it as series combination. The second rod also have taken same length and cross sectional area. But it is material is different. So let me take Young's modulus here is Y2. The first one is different material, second one is different material. So in the first one Young's modulus is Y1 means second one Young's modulus is Y2. Now what happened here? I am attaching the load at the bottom. So by attaching the load means we are giving indirectly force. So what will happen? The first wire will elongate, this first wire will elongate, and that elongation let me call it as E1. Second wire also will elongate because same load is applied here. That means the load attached for the two wires for this combination means force is same. We can tell here the force applied on the both the rods is same. The first rod is also F, second rod also F, I can say. Now suppose if you treat this total combination, if this total combination if it behaves as a single wire, that means single wire, here is the first wire, second wire. So if you take it as a total combination as a single wire, then what we can do now? Let me draw the diagram. And now I am treating it as a single wire. Single wire. If I treat, that means it behaves like a single wire. If you discuss, then what is going to happen? We have to check it now. So as usual, load is attached at the bottom and the mass is here M. What is the total length here now? 2L. But cross sectional area is same. You can observe here one wire length L plus L is 2L. We can write. And what about a cross sectional area? Uniform cross sectional area. Here is also A. This total rod also we have to write. The combination has the cross sectional area A. And let me call the Young's modulus of this one. That means if you treat this as a single wire, if suppose this total combination behaves as single wire, if you treat, then let us take the Young's modulus of this combination is Ys. In series combination we are discussing, so I wrote it as Ys. And anyhow, the force is same. The force, because same load here. See at the bottom load is attached to this one, the force is same. This is the given data. And because now let us take the total elongation as Es. The total elongation as Es. I hope you are clear with this one. What I did? First two rods. First rod, second rod. Two rods I have taken. And in these two rods, Young's modulus Y1, Y2 different materials. Elongations produced are E1 and E2 as the load is attached here. And the total, if you take this total combination as single wire, this is that one. And length is 2L. Cross sectional area is A. And the same force, because load attached here, same force applied F. And Ys is a effective Young's modulus, we can say, of the combination of these two rods, we can say. And Es is elongation of the total two rods. That means Es is nothing but what we can say now? E1 plus E2. Let us see that point now. Es is equal to, what is Es means? E1 plus E2. Now, here we can easily identify that we have one formula for Young's modulus. What is that one? Y equal to FL by AE. From here I can write E is equal to what should I write? E is equal to FL by AY. So here I want E1. For first rod means already we noticed that for first rod if you take, what is the force for first rod? If you go back and if you observe, you will understand that. What is the force here for first rod? F. And what is the length here? You can observe here F. Length is L. Cross sectional area A. Young's modulus Y1. So the things will apply now. So E1 means, first of all, E1 I am applying, F, length is L, and cross-sectional area A, but Young's modulus is Y1. For second order, similarly, force is same, length is same, cross-sectional area is same, Young's modulus is Y2. For the total combination, what will be there? For the total combination, if you observe here, what is the length? 2L. What is the cross-sectional area? A, F, Ys. So now here length is 2L. You must not forget that. Length is how much? 2L. And what is the cross-sectional area? A. And what is the force? Same force, F into Ys here. Now everywhere I can cancel F. Everywhere I can cancel F. And everywhere I can also cancel the length here. Length here I can cancel. And I can cancel cross-sectional area. These are common terms. So what I am left with? 2 by Ys is equal to 1 by Y1 plus 1 by Y2. I hope you are clear with this one. 2 by Ys is equal to 1 by Y1 plus 1 by Y2. So if two rods are in a series combination, then this is the formula for finding the effective Young's modulus if you treat them as single wire. Let us see here. 2 by Ys, just now we wrote 2 by Ys is equal to 1 by Y1 plus 1 by Y2. If you take LCM, what should I write? 2 by Ys is equal to Y2 plus Y1 by Y1 Y2. Y1 Y2. From this, finally I can write cross multiplication. If you do, you will get Ys is equal to 2Y1 Y2 plus by Y1 plus Y2. Just I didn't do anything, just cross multiplication. I send this side and this one and this side, the total Y1 Y2, this term down here, and Ys to other side. Just by doing the cross multiplication, what will happen? 2Y1 Y2 by Y1 plus Y2. This is for two rods in series. For example, suppose you have taken 3 rods in series. Let us take 3 rods in series. What will happen if 3 rods are in series? This is first rod, second rod, and again I am taking the third rod. 3 rods in series. Here Young's modulus Y1, Y2, Y3. And okay, anyhow length and area, lengths and cross-sectional areas are same in all the rods. So that what will happen, we attach the load as usual. Here the rigid support and bottom we attach the load of mass M. Now what we can write means for 3 rods if you are taking, we have to write 3 by Ys is equal to. That means if you take the total and effective Young's modulus for the taking as a single wire, 3 by Ys is equal to 1 by Y1 plus 1 by Y2 plus 1 by Y3. For 2 rods means what happened previously, we got 2 by Ys is equal to 1 by Y1 plus 1 by Y2. For 3 rods means now what we can write? For 3 rods, 3 by Ys is equal to 1 by Y1 plus 1 by Y2. Similarly, suppose they are asking for n rods. For n rods in series. Suppose they are asking for n rods in series combination. N wires or rods, anything we can write. N rods in series combination. So in this regard, what will happen? N by Ys is equal to 1 by Y1 plus 1 by Y2 plus 1 by Y3 plus so on up to 1 by Yn. Like that we can write for n rods in series. So I hope you are clear with the series combination. Series combination means main points what you have to remember. That is, force applied will be same for the 2 rods. And one rod connected at the end of the other rod. This type of combination we call it as series. And if initial length and cross-sectional areas are same, then Young's modulus for the 2 rods we can take it as 2y1 y2 by y1 plus y2. And for n rods means we can write like this. I hope you are clear with for n rods in series combination. Now let us see the parallel combination. I think you are clear with series combination of the 2 rods. So now in parallel combination means how to handle parallel combination. See here, I am taking first rod here and let me take another rod with another color. See here these 2 rods. Now for these two rods, the load is attached at the bottom. So for the same load is attached for the two rods. That means first rod is also attached, second rod is also attached to the load. Such type of combination is called parallel combination. First rod is also attached to load, second rod is also attached to the load. Such type of combination we call parallel. But in series not like that. First rod and second rod and third rod, these three rods are there, but load is attached at the ending of the third rod. But in parallel, not like that. Every rod is connected with the load. First rod is also connected to the load. Second rod is also connected to the load. Such type of combination we call parallel combination. Here also length is L, cross-sectional area L, A. Length L, cross-sectional area A. Young's modulus Y1, Young's modulus Y2 here, the two different materials. And here one thing is confirmed. If the same applied load here for the two rods we are attaching, what will happen? Elongation will be same. Both the wires will elongate in the same because they are combinedly attached with the load. Now first one and second one both are given the connected to the load means elongations will be same. But the force will not be same because one is different material, other one different material. So the first one suppose experiences force F1, the second one will experience force F2. So the force experienced by first and second rod is different because they are made up of different materials. They are made up of different material. Suppose if you treat the total combination as a single wire, the total combination now I am taking it as single wire. What happened now? I treated as a total combination as single wire. Bottom load as usual attached, that one is M. Now this total is single wire I am taking, this total single wire. What will happen to the length? Length is not going to change. See here, this is length L, this length L, same length L because these two side by side we connected. That means you combine like this, side by side we combine like that. It became fat. Fat means cross sectional area will become what? 2A. First one area A, second one cross sectional area A. So cross sectional area A plus A is 2A. But length will not change. Let me take length as L1. Anyhow, the elongation is E. Same elongation means E. Now, here the material, let us take the effective combination YS. Young's modulus for this combination, let me taking it as YS. Now, we can understand the force applied here in parallel combination of these two is equal to the force for first rod and also force for second rod. So now we can also just put the formula y is equal to FL by AE here. Observe here what is F? F is nothing but YAE by L. So let me substitute this formula in the above. What we can write first of all F1. F1 means, observe carefully what is F1 here. F1 for this one. What is Young's modulus? Y1. Cross sectional area A. Length L. So let me write that one. Y1. First what I have write? Y1. Next A. And again elongation E. Length is L. For second rod you observe. Second rod Y2. A. L. E. So second rod also very easy to write now. So Y2 into A into E by L. For total effective combination, what will happen? Cross sectional area is 2A. Length is L only, is E, and this is YS. But cross sectional is 2A. So now I have to write Y. Here what I am taking here? YP. Let me take Young's modulus, not YS here. Parallel combination, right? So let me write it as YP. So YP into, what is the cross sectional area? 2A into, what is the elongation? E by length is L. Now, happily you can understand that we can cancel the common terms. What are the common terms? Length is common term, E is common term, A is also common term. If you cancel this one, I am left with yp is equal to 2 into yp is equal to y1 plus y2. It's a very simple now parallel combination. As you understood series combination, we didn't take more time also to complete parallel. So here yp is equal to, we can write it as y1 plus y2 by 2. Suppose for 3 rods in parallel, if you take, what will happen? 3 rods in parallel means, yeah, let me show you that one. So the diagram I'll show you. 3 rods in parallel I am taking. So 3 rods in parallel means this is the first rod, L and A, and this is the second rod, L and A, and another rod also I am taking, third rod. So in all the 3 rods, what we observe, length and cross sectional area is same, and they are connected to the load. Each one is connected to the load. So this is parallel combination. Let me take the first one material y1, second one material y2, last one material y3. Now as the length and cross sectional area and everything is same, elongation same, so from now I can understand that 3 rods are there means, what should I write? 3 rods are there, yp is equal to y1 plus y2 plus y3 by 3. Similarly, suppose for n rods are there, for n rods in parallel, combination, this is a parallel combination. Now what will happen? Yp is equal to y1 plus y2 plus y3 plus so on up to yn by n. That you must not forget. So I hope you are clear with the series and parallel combination. Series and parallel combination of rods related to Young's modulus. So this is one important application, series as well as parallel. I hope you got idea about how to handle this formulae. Very important for objective point of view. Thank you everyone.